Hey, Matt, and other people that get this video. First of all, I want to apologize. My screen capture software sometimes has artifacts in it, but which I've noticed a lot of times with these sort of drum videos. Anyway, so here's my setup. I've got an actor, which is sort of like it launches the editor, the little pattern editor. And there's not much to it. Basically, I create my main interface widget, which I'll show. We'll talk about all the different components that go into this, but I've got three different widgets, and the main one is loads the editor. The editor then manages the sub widgets on its own, and I feed it a sample bank, and the sample bank consists of about a dozen samples, and these are all samples from my Vermona DRM1 drum synthesizer that I recorded just to play around with this. And so what happens first? So this is just this sort of boilerplate for loading a widget on the runtime. So you create a widget, you cache it, add it to viewport. You set up your input mode. There's a UI mode. There's a game mode. So the UI only mode means that the user won't be able to like interact with the game in the background, but that's basically what you want if you're just like opening a menu and you just want them to sort of do UI stuff. And then I display the mouse cursor. I don't have like a custom art mouse or something like that, so I just turn the mouse cursor on. And then that's it. That's all it's in this little actor. It just launches the widget to the screen and feeds the widget sample bank. So I can change this sample bank to new samples or whatever if I wanted to. It loads this UMG widget, which is super basic. I've got a couple buttons, and then I have this basically it's a vertical box with and a vertical box is basically a widget that can have multiple children widgets. And so you can treat it, it's essentially like an array of widgets. And these widgets are all arranged in vertical order from top to bottom. So in my graph, what I do is presumably when I constructed this object, this widget, I set the samples array, which is a sound base array, to expose on spawn. And that way, that means that the parent, whoever's creating this widget, is basically filling in those parameters. It's a good way to sort of force initialization, to sort of say, okay, on init, you're going to want all these things filled. And in my case, I just want a sample bank kind of loaded in. You don't have to do it this way. You could preload it. It can be part of your class definition. But this way, any actor loading this widget can feed its own custom sample bank to it. That's the idea. Obviously, you could sort of go to town and create some sort of system for like loading new samples and whatever. But this is just how I did it. And then on construct, so widgets, if you're not familiar with UMG, they have events that are pre-construct and construct. So on construction of this widget, I create a Quartz clock for the editor, and I name it, and I give it some generic settings, which is like, common time signature, whatever. I cache it, and then I take the samples and I crawl through my array of samples, and for each sample I create a track widget which intakes a name and a sound. So this is an array of samples, so this is spitting out sound-based object references. And I'm getting the display name of that sound base, and that's the track name I'm just making it the track name, and then the sound. And so each track basically has its own sample that it's responsible for. And then I add it to my vertical box, and then I have some initialization functions. I set the clock. I hard code set the beats per minute for the clock. And this is actually, this doesn't be done every single time. This can be done on completion. So, but you know, you could have some sort of interface where maybe you can tweak the beats per minute. I just didn't for this because it was just like a quick and dirty kind of test. And then this is one of the buttons here. This button right here. This either says play or pause based on the state of the clock. So it initializes with the word play as it's, and then you can see here when it's clicked, it will either pause the clock or resume the clock. And the text will change accordingly, so that you know that, hey, when you're when it says play and you press it, it will play. When it says pause and you press it, it will pause. Basically, that's how it works. And then the other button, which was reset, goes through, it resets the transport. Not that that's particularly important. This is what's really important. This is how I'm doing my counting. Each track is basically keeping track of its own counting because they're all asynchronous. So I go through each one and reset each individual track's thing. So this was actually superfluous. I didn't need to do this because I didn't end up using that. I think the only thing that happens is technically I won't get past this validated get if the clock is not validated. So the clock has to be valid first. All right, so that's the main interface. Then on the track, the track is pretty simple. Basically, I've got a track name. That's what you fed in. That's one of the parameters that was fed in on construct. And then I have these two buttons, a plus button and a minus button. And then you can't see it, but right here I have a horizontal box. And so on construction, I set up the name so that the UMG, the text UMG, now has the proper name, whatever the asset's display name was. And then I have an add step and remove step, right? That's it. Add step and remove step. And on the add step, basically I have a map. And this was a gotcha that I sort of screwed up. Length and index. I probably should have limited that 16 because I can get excuse me, I can get one extra out of it than I actually needed. Then when I add a step, I create a step widget. And the step widget just manages its own sort of state. So it's very modular in this way. Each step basically has, you know, am I lit? Am I not lit? And then this one's very simple. I just add it to the map, and then I add it as a child to the sort of horizontal box. When I remove a step, I make sure that the length is not smaller than my minimum. right? Yeah, basically making sure that it's greater than 0. And that's just because if you put in some wacky index here, you'll get an error, and I just don't want to mess around with that, right? We just want to make sure all of our indices are valid. And then I basically find the last index, so the length -1. I find the last index and remove that child and remove that index from the map. So what happens at this stage, and this is kind of a thing you got to sort of appreciate about Unreal. This is a very Unreal thing. There's this whole thing called UObjects that is essentially part of a memory management scheme, a garbage collection scheme. So when a UObject-derived object, which is basically almost every object that in at least in blueprints, like this level, if you have a UObject that is not referenced by any other UObject, what happens is every once in a while garbage collection comes around and looks for orphaned UObjects and goes, hey, you are not referenced by anyone, so I'm going to clean you up. That's what it does. So on the one hand, this can be very convenient because here I'm not destroying this object, this step box, this step. I'm not destroying it. All I'm doing is removing all references to it, and I'm gonna let garbage collection deal with it whenever it wants to deal with it. Okay. But in the case that I was talking about in the forums, audio components, I've got all these audio components. Audio components are the sort of game thread proxy for the sound. And if garbage collection cleans up those audio components before the sound gets to play, then the sound will probably not play. Or there could be some issue that comes up that we haven't tested yet. And so I need to retain those audio component references just in case. I could probably get away with not doing it, but because garbage collection is not every frame, it's every once in a while. But I don't want my thing to not work every once in a while. I want it to work all the time, and so I retain those references. And so what I really need to do in my case is the tracks themselves. And I'll show here we have let's see. Well, when I get to it, you'll see that the track, excuse me, the track basically has an array of audio components that it just keeps filling. Audio components are set to auto destroy when they're done playing, but the array doesn't get pruned. So what I could do is do something very similar to garbage collection, where every once in a while I sort of step through the array and just look for invalid elements and then just get rid of those indices. But I just haven't done that. So that's why I wasn't keen on just showing off this stuff. Anyway, so we've got a little bit of an API. We've got the set clock. Boom. The clock just passes in the reference. So that way the parent that creates this track can pass the clock reference to it, so that all of the tracks will share the same clock reference. And then I create a subscription right off the bat where I subscribe to all the events. The other one that you saw me call was reset clock. And here I have every track has a playhead. Every track has its own playhead. And so I have a playhead index. And then on my this is why I didn't always like showing this stuff. This is a little messy. But here's my subscription to the clock. So what this means is every time every quantization event is basically what I've subscribed to. So every track is subscribed to every quantization event from this clock. What's going to happen is on the game thread, it's going to come up with a big, huge list of all the scripts running. And then it's going to run through all of them. So all the delegates waiting to execute will execute. So all of these tracks will actually execute their subscription on the same game thread frame. If there's a lot of stuff like this happening in the game itself, then that can actually slow down the game thread, right? Okay, so here, basically, and this is where I could make it leaner, is I could only subscribe to 2, because I ended up only using beat and 16th note. So I could subscribe just to those 2 events instead of subscribing to all of them. But when I was sort of throwing this together, it was very convenient to just subscribe to one that was all of them, and then just do that. But yeah, these can be separated out into 2 separate functions, and one being a beat subscription and one being a 16th note subscription. On the beat, basically what happens is I look at my step map, all right? And essentially, and the keys for the step map are the indices of the steps, right? So in that way, I could have used an array, but a map, for whatever reason, was just what I ended up using. I didn't have to deal with, taking something from the back. I don't know. It was easy, so I ended up using a map. But yeah, this could probably be leaner with an array. And then what I do is I loop. I just create a 4-step loop. All right. And then what happens is I first so basically I'm like wherever my playhead is, right? Plus the +1 of my loop index, my array, my for loop. So I do like a for loop that is 4 steps long, and then I add 1 to my I on my for loop, and then that gets added to the current playhead index, right? And then I use a mod on the length, and I find that step. And so what this does is it's basically my wraparound. So if the step map shrinks while it's queuing up, essentially, then it will shrink accordingly, right? So the length is evaluated to ensure that I don't go out of bounds. And so, and it'll just wrap around from the 0 index, which is very handy. So that means essentially the idea is I'm always queuing up 4 16th notes at a time. And I'm doing this so that I don't have to worry about the frame rate. 1 beat is plenty of time to queue up. And that means so this is a safety feature for me. I know that I don't I probably could do this every 8th note instead of every quarter note, right? And it would probably be fine. But doing it this way means I can be absolutely certain that all 4 of my possible patterns will be queued up. Now, what that means is that if the pattern changes before it hits those, then it will be off from what the user has set. But it's moving so quickly that 130 beats per minute that I think that the user's probably not going to notice that much. And it's very much aimed like a toy. But if I needed it to be more accurate, then that's something that I could negotiate. I could queue fewer up in advance more frequently to try to ensure that the pattern is always close to what the user has asked it to be. And so then I create my component, and then I play quantized on 16th note, and then here I use the multiplier to determine which 16th note, the first, second, third, or fourth one, based off the current time relative. And then every 16th note, I go through and I go through my map, and I set the state of the actual step itself, and so that this is basically so that I can light the step if it's the same step as my playhead. So basically, I'm just setting the because you'll notice the steps have like multiple phase. They have multiple states. They have like a normal state and a playhead state, and then they can also be like lit, right? Selected or whatever. And then I go through, let's see, step map, last play index. So, right, so the last one, and I set that as normal, right? So this was just incrementing my playhead. And then, let's see, the last, and then I just update the last playhead index. So I'm keeping track of the current playhead index. I'm keeping track of the last play index. Right, so that the current playhead index ends up lighting up on my UMG, and the last one is reset to be like a non-playhead indicator, and then and that's it. And then so on my step, on the step itself, excuse me, on the step is very simple. It's just a couple of boxes. I've got a border and a step box, or this little checkbox, sorry. And if we look, we've got initialized state of normal, and then that's it, right? Because it's just for painting it. And so when we set the state, whatever it's set to, I just change the color of my border. From a basically an invisible border to a green border. All right, so I can save. Sure, that should still work. So when I load this up, right, these steps all have invisible borders. When I start playing it, you'll notice that it didn't even start on the first one. I wasn't worried about that. That's something to work out in my code, because I didn't, that was something I didn't, some sort of situation where I'm not like, for some reason I'm one behind or something like that. It was like off by one or something. But what's nice about that wraparound, all those mods, is that I can increase the length and decrease the length. And the playhead doesn't, it still kind of works, basically. And in reality, the playhead is actually latent. It's actually latent. But it's not bad, right? Now, my frame rate's probably high, but, that's only part of it. So yeah, that's how it works, and this is just my custom enum, because you can create enums and structs and blueprints and stuff like that. So yeah, that's basically how it works.